The mission of Oak Ridge National Laboratory's transportation program is to help our nation reduce its dependence on petroleum. We work very closely with relevant government and industry stakeholders using our expertise in material science, neutron imaging, computing, mechanical engineering, chemical engineering, and electrical engineering to develop more energy efficient vehicle technologies and to also make our transportation systems more energy efficient. Here at the National Transportation Research Center, we have a collection of science tools that are fairly unique, and we have the Department of Energy's only user facility focused on transportation. We have research capabilities for fuels, engines, and emissions, for electric drive technologies, for energy storage, transportation analysis, materials, vehicle systems integration, vehicle security, all the relevant technologies related to making vehicles more energy efficient.
Fuels, Engines, and Emissions Research Center is part of the National Transportation Research Center at Oak Ridge National Laboratory, very much focused on accelerating the development and deployment of advanced technologies such as advanced engines, emissions controls, fuel and lubricant technologies. Co-optimization refers to the co-optimization of fuels and engine technologies. And the idea is that if you do this at the same time, do the co-optimization, that you're going to get the best of both. It's a synergistic relationship. With modern high-efficiency combustion engines, one of the challenges is the fact that they are so efficient. So now the exhaust temperature is very low, and the problem is after-treatment systems, as we currently use them, will not become active at those low temperatures. So in other words, they're not doing their job because temperatures aren't high enough to get them going. So a very strong point of research is low temperature catalysis. The Department of Energy has a strong thrust here, industry has a strong thrust here, and we work very closely with them to enable low temperature catalysis.
The Vehicle System Integration Lab enables research at the Powertrain level. And what we focus on is the integration or the coordination of the components that make up the powertrain. Normally a powertrain is installed in a vehicle. Well, in our case, the vehicle is not there. We have the powertrain in a test cell and we emulate the vehicle. So we can change the way the driver behaves, we can change the type of vehicle, we can change the roads, the grades, and all this at a click of a button. Our additive manufacturing colleagues build a vehicle. So we had to develop a powertrain for a vehicle that did not exist. Hardware-in-the-loop testing allowed us to debug that powertrain in the test cell, develop the controls such that when the vehicle was eventually ready, we could just install the powertrain seamlessly into the vehicle and drive our way in record time.
The Battery Manufacturing Research and Development Facility is a facility which has been established within our cross-section of the National Transportation Research Center and the advanced manufacturing portfolio we have here to investigate and further develop the way we manufacture batteries and in an overall scheme other energy conversion and energy storage devices. We thought long and hard about how to best set up a facility like this to ensure that we can benefit small companies in specific and build a supply chain for energy storage devices.
Power Electronics and Electric Machine Research Center, or as we call it for short, PMRC, was established to reduce the cost of the electric drive technologies for electric vehicles. So with that, we're mainly focusing on power electronics and electric motors for the vehicles. And we're trying to find out how we can develop technologies that would reduce the cost of these vehicles, increase the power density, basically lower volume, and see how we can make them more efficient. We have this wide bandgap characterization facility, so we can put these devices or the modules in our characterization facility so we can get actual characterization of these devices or models of these devices for different temperatures and for different operating conditions. We started working on wireless charging maybe 7-8 years ago. We were the leading institution in the US. The last few years we've been looking at how we can, under a DOE 4, how we can retrofit some RAV4 EVs, how we can retrofit them with wireless charging so we can use them for opportunity charging. We're trying to advance the wireless charging technology, looking at different topologies, looking at different technologies, like wide bandgap semiconductors, and looking at different coil designs to make sure that we can get high efficiency, high power wireless power transfer.
We recently established a new vehicle security laboratory at the National Transportation Research Center, and the reason that we did that is because as we move towards more autonomous driving, we're going to have vehicles that communicate with each other and also with infrastructure, and we need to make sure that those communication channels are secure.
We have specialized scanning equipment to monitor vehicle networks inside the vehicle, but we also have radio scanning equipment to monitor Wi-Fi, radios, GPS signals coming from outside the vehicle. We're going to be also using some software that was developed by other parts of the lab that monitor controller software for modifications that could be due to a hack.
The Oak Ridge National Laboratory's National Transportation Research Center is a national asset for the transportation community. We work very closely with industry, and we love listening to their problems and helping them come up with solutions. So please come and visit us, and let's talk about some of your most difficult challenges and how we can use our great science tools here to help you solve them.